Hi there, this is Jacob Nash Engineering Lessons for Principles of Engineering, and this is Unit 1.2, Lesson 5, on how to solve for different circuits, both series and parallel. So first, let's look at an example of a series circuit. So, first of all, there's 3 different things you need to consider when solving a problem. Number 1, you need to figure out if the circuit is series or parallel. It might say it in the problem. For some, in some cases, it might be already drawn out anyways, and you would know from that. But a series circuit, actually realized just now I forgot to do that in the last video, but what a parallel circuit looks like. But a series circuit, I already said, it has only one path, and it might look like this, depending on how many resistors it has, but let's just say it had 3. That's a series. It only has one path, which would be this red path. But in the case of a parallel circuit, it would look like this. It would go here, and then, wait a second. Hold up. I think I did something wrong here. Hang on. Oh, sorry about that. I was looking at the wrong thing. It's actually this. There's a resistor there. Then there's another one here. It might not be exactly like this. Like I said, it would depend on how many resistors there is. And it would look like that because there's multiple paths to go on. If one of these was cut or taken away, it could still go on a different one. So that is a series. Terrible writing. Series. This thing. I'm about to be done with this thing. I'm just trying to write it and it's not coming out. You know what I said. Series. And then parallel. I'll just do that. Parallel symbol. Okay, let's delete that all. So once again, the first thing you should do when you're solving a problem is figure out if it's series or parallel by reading the description or seeing an image. Second thing, which you may or may not have to do, sketch. If it already is sketched, then you don't need to do that. And I'll show you how to do that. So then, you'll need to write out the 4 rules for that type of circuit. Now I told you what they were. So for well, actually, I'll just tell you. So, an example of it for a series circuit. I already told you what it was, so we can skip number 1 because I already just said what it was. But so let's just see an example we have here. So there's a series circuit. It is going to look like this. Here's the battery. Then there's a resistor right here. Oh, what is it doing? Then another resistor right there. And one right there. If you ever watched my geometry videos, I did different things. Like I sometimes used Google Slides or Wixie.com, but it's not very easy to draw with the mouse either, so I thought I could go on my tablet here and use a stylus, but I'm getting an iPad in a few days, so maybe the stylus will work better on that, but we'll see. So then some information. So we can say that Oh, okay. So right here there's 10 volts. And then for this resistor, it has 180 ohms. Then for the second resistor, it is 640 ohms. And then the last one, it is 330 ohms. And things that it wants us to find is total resistance, total current, and total voltage, as well as voltage V1, 2, and 3. So that's things we need to find. First, let's start out with the total resistance. So for a series circuit, remember the rule. The 4 rules for a series circuit that I already mentioned is that it has a single path. The total current is they are all equal to each other, each component. And for the total resistance, you add up each resistor amount. And then for the total voltage, it's the sum of all of them. So, okay, we know we have to add them up. So I just said that the sum of all the different resistors. So R1 plus R2 plus and so on, depending on how many there are. In this case, it's 3, so we'll add R3 in there. And let's just say this is 1, this is 2, this is 3, but it doesn't really matter which one you choose. And we can add them. So 180 plus 640 plus 330. Let's see what that is. Oh, I typed in 30. Great. Okay, let me try that again. 330. Okay, the answer is 1150. 1150 ohms. And I bet in some problems you have, they might say, like, have an example where it's like micro ohms or nano ohms, and you'd have to convert to just standard ohms. And lesson 1, I show you how to do that. So see that if you need to know how to convert units. Then so that was the total resistance. Now we need to know the total current. And okay, I think that is really annoying. Okay, almost done here. Okay, let me pause to let this dumb thing erase. Okay, that's better. Now the total current. Well, that is all of the components equal each other. So I1, I2, I3. So well, then you're like I'm gonna have to call an NP on this one, which no point. That's what that means. And why you might do that is because you're like, what the heck? You don't have any of them. You don't have IT, you don't have I1, you don't have I2, I3, any of them. Well, whenever you have to call an NP, you should use Ohm's law. And I said that in Ohm's law, you can use the triangle to find the different relationships between voltage, current, and resistance. So, since we're trying to find the current, we know that that is voltage divided by resistance. And in this case, since we're doing IT, we can do total voltage over total resistance. Well, do we know any of those? Okay, so we know what the total resistance is. We just found that. That was 1150 ohms. But what is the voltage? Well, we didn't even say what that was. But actually, any time there's something listed right here by the battery, that is going to be the total voltage. So that kind of already answers one of the other things we have to find. So 10 volts divided by 1150 ohms. Oops. That is a very small number, but it's 0.0087 approximately. And so that is the total that's the total current. And if they asked you for the total or for I1, I2 or I3 or any of them, you would just use that because oh, sorry, I forgot to add the units. Remember to add your units. It would be amps, A, uppercase A, amps. And I added ohms and volts for the other ones, but so it would be the same because they all equal each other. Now we need to find the total voltage as well as V1, V2, and V3. That's the last things that it asked. Or really that I asked. Okay. Oh. Don't know why that I try to erase it and then it just comes back sometimes. I just lift up the stylus and sometimes it works better. Okay, any day now. Okay, there we go. Good enough. Now we need to find the total voltage. Well, we already said that was 10 volts. And we also need to know V1, V2, and V3. So how are they related to the total voltage? Well, we said that the sum of V1, V2, and all of the components, which there's 3, since there's 3 resistors, the sum of them equal 10 volts. So you have to call another MP because you're like, okay, well that's not even possible right now because we don't know any of the V's. We only know the total voltage. We don't know V1, V2, or V3, and you can't solve if you don't know them. So we have to, once again, go to our Ohm's law. That's what I said. Anytime you have to call NP, go to Ohm's law and figure out the relationship. So since we're trying to find V, we know that that's I times R. So what is, and we can plug in any number, so for V1, V2, or V3. So let's start with V1. So V1 is going to equal I1 times R1. So what is I1? I1 is going to be 0.0087 amps because remember all of the I components equal each other in a series circuit. So we have 0.08 or 0087 amps. I'm lucky I remembered that. Times the first resistor, and that is right here. So 180 ohms. So you multiply that, and you get approximately 1.57 volts. So that would be V1. Then V2, see if I can, not a lot of space to write on here. So once again, I2 is going to be, so it's going to be I2 times R2. And I2 is 0.0087 times the second resistor, which is 640 ohms. And I'm sorry this is so messy. This terrible app, really. And that is approximately 5.57. So that's V2. Then V3 is going to be I3 times R3 using Ohm's law. So I3, once again, is going to be 0.087 amps times the third resistor, which is 330 ohms. So that is approximately 2.87. So I'm going to recircle things in blue so they stand out. That's my 3 answers. There is a way you can check your work, luckily, so that you can make sure you get it right. And that is Kirchhoff's current law. Or Kirchhoff's current and voltage law, but in this case we're going to use the voltage law because we're dealing with volts. And so that is that the sum of all the volt components equal the total voltage. And the Kirchhoff's current law is that all the current components equal the, added together equal the total current, sorry. But that's only for the parallel circuit. Remember, for this one, they all equal each other. And I'm sorry if this seems confusing. Sorry that it's all cramped together, but I'm only saying this Kirchhoff's law to say that's how we can check our work. So we add these 3 answers together, and do they equal this 10 volts? Let's see. So 2.87 plus 1.57 plus 5.57 equals 10.01, and I know it's not exact, but that's because we did some rounding, and so it's about the same thing, so that means we got it right. So that is only the first part of this video, and sorry that this is probably going to be a long one, but that is how you solve things for a series circuit. Parallel circuit is close to the same thing, but you have to do things a little bit differently to solve for each of the 3 components. So let's come up with a different example. So now we have a parallel circuit. Here's the battery. Let's just make it have 3 resistors like last time. Let's say that there is let's just say that there is 4 volts right here. Then we have 5k ohms, 4k ohms. That's very messy. And then 3k ohms. So sorry that is so messy. I wish I could do something a different way, but just try to listen to what I say. So let's say that this is the first resistor right here. This is the second one. This is the third one. Now, let's say the things that we need to find are first the total resistance, the total current, as well as the I1, I2, and I3, and then the total voltage as well as the V1, V2, V3. So first, total resistance. This is the one that's a little bit tricky. The equation is 1 divided by the sum of 1 divided by first resistor plus 1 divided by the second resistor plus 1 divided by any amount. You just keep adding depending on how many resistors there are, but there's 3, so I'll do this. So we can plug in. So 1 divided by 5k, which just means 1,000. Well, it really means kilo, but you can just change that to 1,000 ohms, plus 1 over 4,000 ohms, plus 1 over 3,000 ohms. So we add that together. 1 1 divided by 5,000 plus 1 divided by, or yeah, you have to do that in parentheses or it might not do right. So remember, do that in parentheses. Plus 1 divided by 4,000 plus 1 divided by 3,000. That is an insane number, which is 1 divided by 7.3 e to the negative fourth. Now, what you should do on your calculator is so this is what we've come to. This is our equation now. So do 1 divided by second, and then if you see A and S, which means answer, so that you don't have to type that in, then push enter, and it gives us approximately 1276.5. Oh wait, no. I guess about 1276.6. And let me actually just write that down so we can use that later. Okay, ohms, remember that. And that's a total resistance. Now we need to know, okay, it just deleted the whole thing. Let me erase. Okay, that's better. I rewrote that thing, so that's supposed to be 4 volts, and then now we're trying to find the total current, so IT. Well, that is the sum of all the different current components. So that we can use Kirchhoff's law to check our work later on. So first of all, we have to call NP once again because we don't know any of those. So remember, I equals V divided by R, so we have to do that for each one. So V1 divided by R1, and then V2 divided by R2, and then V3 divided by R3. So I'll just do the work for that, and then we'll see what we come up with. So this is what I ended up with. So the V1, V2, and V3 are all the same. We're one step ahead because they all equal the same in a parallel circuit. And so then the bottom was just the 3 resistors, which was 5K, 4K, 3K. And we divided those, and I got 0.8 amps, 1 amp, 1.33 amps. So using Kirchhoff's law, we should add these and get the total voltage, which is 4. So I'm adding them, and I get 3.13. And that, if you think about it, that actually rounds down to 3. But it is pretty far off because we rounded pretty heavily throughout this problem. If we actually went with the actual numbers, it would definitely come out to 4 exactly. But it's a little bit off, well actually a lot bit off on this one because of that. But that's okay. So we know we did it right. And then now the last things that it told you to find were the total voltage and all 3 of the different components. But we already did that because, remember, for a parallel circuit, the total voltage equals all of those. So it's 4 volts is the total voltage, and since we know that equals all of them, then it's 4 volts for all of them. So that is it for this problem. The one last problem that there might be an example of is this. So let's say it's Christmas time. Will be before we know it anyways, if you're watching during when I made this. So we have some Christmas lights here. I'll just make them all red. so we have Christmas lights here, and let's say one of these lights burns out, and then after it burns out, so let's say this one burns out, so exit out. Well, after that, all of them are gone. It's just it completely burns out. Would this be a series circuit, or would it be a parallel circuit? So it would be a series circuit because it wasn't able to find another path. That's why they all burnt out, just because one did. Because that was the only path it had. And that means that it just messed the whole thing up. Now, if that one burned out and the other ones didn't, then it would be a parallel circuit, because the other bulbs found a different, or the electrons found a different way to go to light up the other bulbs. So that would be it. I'm sorry that this is a very long video. I can't talk that fast with my oral injury, or that it was 80 degrees in my house. So sorry about that is so long, but I hope it helped, and if you have any questions, feel free to comment below. Thank you for watching.